So we have two more trace minerals to go, chromium and fluoride. There are some other trace and ultra trace minerals such as molybdenum and arsenic and lead and those sorts of things that we don't really usually think about as being food related, but we think of them as being poison. We need an ultra trace amount in order to function in our bodies, but they're very hard to study, and if you choose to continue on with your nutrition studies and go to Nutrition 230, then we will talk about them there. So chromium is a component of the glucose tolerance factor, which is a small peptide required to maintain normal blood glucose levels. The RDA for men is 35 micrograms per day, and for women is 25 micrograms per day. Sources include liver, brewer's yeast, nuts, and whole grains. Deficiency is quite rare in the US, but people with type 2 diabetes or sleeping problems and things like that are starting to be given some chromium to regulate blood sugar. Excess, there's little evidence of that, but as we start supplementing, we always start seeing some sorts of excessive effects. So I'm sure as the supplementation becomes more popular, we might see some excess effects there, or toxicity effects. And fluoride is our last one. So fluoride's incorporated into crystals in the tooth enamel, which then protect against cavity-causing acids produced by bacteria. In the saliva, it decreases bacterial acid production, inhibits dissolution of tooth enamel by acid, and increases enamel remineralization after acid exposure. It's also incorporated into crystals and bone. Now, this all sounds well and good, but the reason fluoride does that is because it's very toxic to the blood. So there's a lot of controversy over whether or not we should add fluoride to our town water. The RDA is 0.05 milligrams per kilogram per day, so it's dose dependent on your weight. The UL is 0.1 milligrams per kilogram per day for infants and children less than 9, and 10 milligrams per day between 9 and 70. Sources: in small amounts, it's found in almost all soil, water, plants, and animals. It's also in toothpaste, certain teas, marine fish with bones, and fluoridated water, which can be tap water in some towns. Deficiency could put you at more risk of cavities or tooth decay. Excess causes fluorosis. So fluorosis happens when fluoride ends up almost crystallizing and taking over the calcium in the teeth, causing black and brown stains and cracking and pitting of the teeth. It's called mottling of the teeth. So you can see too little fluoride makes the teeth susceptible to cavities. However, too much fluoride can start seeing white spots at first, and then you can start seeing these brown spots and pits and stains, and that's called fluorosis. Manganese is a constituent of some enzymes and an activator of others involved in carb and cholesterol metabolism, bone formation, urea synthesis, and oxidized damage prevention. So we've talked about a number of minerals that are involved as antioxidants, and those so far would include iron, zinc, copper, selenium, and then manganese. The RDA is 2.3 milligrams for men and 1.8 milligrams for women. Sources include whole grains, nuts, legumes, leafy green veggies. And molybdenum, as I mentioned, is a very small little amount of mineral in terms of how much importance we placed on it. It's needed to activate enzymes that function in the metabolism of sulfur-containing amino acids, production of uric acid, oxidation and detox of other compounds. It's readily absorbed from food, so we really don't need to worry about it too much in terms of our food supply. And it also makes it sort of hard to study because it's just like iodine or selenium, it's really variable in soil. It's regulated by excretion in the urine and bile. For adults, we need about 45 milligrams a day, and sources include milk, organ meats, bread, cereal, and legumes. So here's a summary of our trace minerals. We've talked about iron, copper, zinc, and selenium, as well as iodine, chromium, fluoride, and then manganese and molybdenum. So you can see here in table 8.4 all the sources, the recommended intake, major functions, deficiency and toxicity symptoms, groups at risk for deficiency, as well as the UL, or the tolerable upper level of intake. So if you're thinking about what you should eat in terms of minerals, you want to stay hydrated and keep that water intake up. You want to increase your potassium and decrease your sodium intake. You want to make sure you're getting calcium into your body and your bones. You don't really need to worry too much about phosphorus, but you do want to maximize your magnesium and get all those green leafy veggies and whole grains in there. That's one that's not added back to the enriched grains. Add more iron and increase your iron absorption through doing things like more vitamin C and a little bit less calcium along with the iron intake. Think zinc, get those zinc-rich substances with your leafy greens, your whole grains, and your milk and meat. And then trace down your minerals. Understand what the toxicity and deficiency symptoms are of these different minerals and vitamins as well. As we look at chapters 7 and 8, a lot of what we learn about vitamins and minerals we might not have known before Nutrition 101. Our society is so focused on macronutrients that we don't often talk about how to maximize our nourishment. And this is really what nutrient density is all about. It's how many vitamins and minerals can we pack into our nutritional needs. So that's the end of minerals. Feel free to comment and ask any questions that you might have after chapter 8. We've gone through 20 minerals here, which is a whole lot in a short chapter. So feel free to ask questions. Feel free to look at those tables 8.1 through 8.4 in your book, and let me know if you have any questions.